Hello students, Professor Benavides here. Let's finish part 3 of chapter 3. And this section is going to be all about sorting, and we'll also talk about some other topics and sum up stuff. So sorting a list. The sort method changes the order of a list permanently. The sorted function, on the other hand, returns a copy of the list, leaving the original list unchanged. You can sort the items in a list in alphabetical order or in reverse alphabetical order. You can also reverse the original order of the list. Keep in mind that lowercase and uppercase letters may affect the sort order. So let's start with the sort method, which, as I just said, sorts a list permanently. Okay, so here on line 2, I declare my list, and then I'm just going to go ahead and show it to the screen on line 4. I'm putting a little print statement above it so that I know that it's the cars list, original unsorted. Then I'm going to go ahead and sort it, the cars list, and that's done with the dot operator. You list the name of the list, which is cars, dot, since it's an object. Sort is a method. And in this particular case, it's not receiving any arguments, so it just performs the sort. So these items in here will be sorted. And so I just say, hey, it's the cars list sorted with the sort method, permanent. And I print the list on line 8. So print cars prints the cars list, and it should be sorted. And then what I go ahead and do is I use the sort method again, and I pass reverse gets true. So this is in reverse alphabetical, and let's just take a look at this. So I ran it. So I get the original list is BMW, Audi, Toyota, and Subaru. Then I go ahead and sort it, and of course it's Audi, BMW, Subaru, Toyota. And then to sort them in reverse alphabetical, it's Toyota, Subaru, BMW, and Audi. So this works out really good. It picks some really good names because it kind of like goes almost the whole alphabet. I can do this sorting in my head pretty good, and I know it's being done right. So the reverse sort is done by passing reverse gets true to sort. Okay, so this is our first little demonstration of using the sort method. Let's go on to our next one. In this particular case, we're going to contrast the sort method with the sorted function. Okay, so before we used a dot operator, and this time we use a function, and I see it right here on line 8. So this statement says print sorted, and it receives the list called cars. Let me go ahead and run this. And so the first, on line 2, I go ahead and initialize and create my list, and then I say cars list in original order. Fine. That's just to get our head screwed on to make sure that, so that we can see what's going to happen. We can verify things. The cars list sorted with the sorted function. Now this is temporary. So I sort it and I send it the result. The result of the sorting is sent to the print method. But then when I print the car list again, I see that they're back in their original order. Okay? So the original order was not modified. Okay? So the sorted function returns a copy of the list, leaving the original list unchanged. Okay? Go on to another example here. Let's see here. In this particular one, just want to make sure I've got them all. But I had it as cars 3. Let me see if I'm missing a file. Okay, so yeah, I was missing a file. Okay, so I just went over cars 2. I'm going to cars 3. And in this particular case, we're sorting a list using the reverse method. So on line 5, I simply create my list and then I print it out. Let me go ahead and just run it so we can see some. Then I use the reverse method on the cars list and print it out. What do I get? It's the cars list sorted with the reverse method. Now, if I reverse it again, everything goes back to the way it was. Now, so the reverse method changes the order of a list permanently, but you can revert to the original order anytime by applying the reverse method to the same list again. And that's what I did here to prove that, here's the unsorted list. Here's the sorted list with the reverse method. And so remember here that the reverse method, it simply reverses the order of the list. Don't get it confused with an alphabetical kind of thing. It's the order of the list that is being reversed. Okay. All right, so let's go on to our next demonstration here. In this particular one, we're going to go ahead and talk about the length function. And line 5, I go ahead and create my cars list. And I could just say print and pass it len of cars. But what I did here is I called the length function, len function. I passed the cars list, and the return of that, I'm putting it into a variable called length. Then I created a little formatted string. So yeah, I embellished these things a little bit, but I think I'm bringing out the qualities of the the chapter that's in the book. The chapter that was in your book used a terminal window to do this, and I'll probably demonstrate that to you also. But notice that in line 8, I use a little placeholder here, and I put in length. So here's the output. The length of the car is 4. Just to go ahead and go along with the book, the author went to the command prompt and started a Python terminal session. So I'm going to go ahead and say cars gets, and we'll have open and close curly brackets. I might as well just put open and close and then come back to the middle, and I'll list my cars. BMW, Audi. Never did like the Audis. Did you ever have one? My aunt had one, and I was not too impressed. I do like the BMWs, especially the classic ones. Oh my, the older ones is the ones I like. Subaru, haven't made up my mind on that one yet. So there's cars. And so if I just say cars, it restates it. But what I want to do is to find the length of cars. And that's what the author of the book did. Instead of using a file like I did, this was the actual demo that was used. so the length function here receives an argument, cars, and cars, being the string, it counts the length. And this is important to know because many times some people get mixed up with the length of a list. And it's an important thing to know because we use zero-based counting. Okay, so the index value, the highest index value, it's kind of like arrays in Java. The highest index value is one less the number of elements in the array. So if length is 4, well, the highest index value is 3, right? So right here we've got BMW being 0, Audi being 1, Toyota being 2, and then Subaru being 3. Okay, so this, I know we've been talking about this since the very beginning, but it's really important that we get this zero-based counting down. And so we many times go ahead and get the length of a list so that we can make sure that we're doing the zero-based counting correctly. So let's go ahead and exit here. I'm finished with that little demo. Of course, you can always just close the window. All right, so now that brings us to, let's go ahead and go through some of the you try it exercises, okay? So the first one on here is 3.8, seeing the world. And I'll just go ahead and run it so it won't interfere. This one was kind of interesting. Oh, it's a lot of code though, right? A lot of code. See if I can. So on line 1, we create a list of and call it locations. And it has the Himalayas, the Andes, Tierra del Fuego, Labrador, and Guam, right? These are places that you'd like to visit. You can put in any 5 places that you like, right? So what we're going to do is we're going to go ahead and print out the original locations, right? That's line 4. And then what we're going to do is we're going to go ahead and sort it, this list, temporarily with the sorted function, right? We pass the return of this is being passed to the print function. So it's like embedded, right? So what happens here is the inner function gets done first, and then the result of that is sent to print. So then when I show the original order, I should be, when I print locations, I will notice that it's back to the way it was, right? But then I go ahead and use sort, because we're using sorted rather than, sort, right? So this case, it does not modify the actual list, right? Because it's sorted. I have to remember that. So we proved that by showing the original order again. Now we go to the reverse order. It changes the order, not alphabetical. It's a permanent thing. So I just said reversed, and I print out the locations. And then I send everything back to the way it was. It may not be exactly like what the exercise asks for, but I think I'm exercising what we need to learn. If you reverse it, after you reverse it, you go back to the way it was, right? In distinction to sorted, the sorted, function, we're talking about now using the sort method, and this is permanent. It's an alphabetical sort. It is permanent, and we can also go ahead and use the pass reverse gets true to sort. So did I run it? And we can go ahead and look at some of the code on here. So you can see the original list. Then we do an alphabetical. And then we show it again that it was not affected because we're using sorted, which uses a copy, right? And then I go ahead and do the reverse order. So here they'll fuego becomes first, and then we go back to the original order. Excuse me, this was reverse alphabetical, right? Reverse alphabetical. That's this one right here, sorted. And then we show the original order. Then we use reverse, which shows Guam, Labrador, Tierra del Fuego, Andes, and Himalayas. This was the first one, now it's the last one. And then we show the original order again. And we do that, get to the original order by using the reverse method on the list that was reversed. So it puts it in the original order. Then we go and do a real alphabetical with sort that is permanent, and go ahead and reverse that. So then that would take it to a reverse alphabetical order, which would start off with Tierra del Fuego, Labrador, Himalayas, Guam, and Andes. Okay, very good. Let's go ahead and go to 3.9. And 3.9, go ahead and run it. What happens here? We're going to make a list of 3 people to invite to dinner. What's a dinner party, this guy, right? Use a list to print a message to each person and invite them to dinner. So I go ahead and declare my list on line 4. Line 5, I go ahead and print it. And then on line 7, I use the index values to access the element and change it to title case and assign that to the variable called name. I do that again for the second element, the third element. Then I throw in for free the len, or the length function, and I apply it to guests. And I make a formatted string to show the number of guests invited. Okay. So the len function, it says here, use the len function to print the message indicating the number of people you're inviting to dinner. So the number of people inviting to dinner is 3. 1, 2, and 3. So Guido, please come to dinner. Jack Turner, come to dinner. And Lynn Hill, come to dinner. That is 3.9. All right, so then we have, let's go ahead and talk about the off by 1 errors. It's a common situation, and I think this topic probably would have been better when we were talking about the index values in the beginning of the chapter. But some people have difficulty mastering this zero-based counting thing. So here I have a list on line 6, and Honda's at index 0, Yamaha's at index 1, Suzuki's at index 2. But sometimes maybe on our head we'll do something like this. I commented out the offending line. So they'll say something like print motorcycles of 3. There is no 3, right? It's 0, 1, 2. But if I do this, if I run this, I get an exception. He hasn't introduced that word yet in the book, but it is a, he refers to it as an index error. The traceback, if you look at this, the traceback says it's an index error, list index out of range. It's out of range because I'm trying to get index 3, and index 3 does not exist. So it crashes. So basically what I'll have to do is get rid of this And what I could do is, you know, if I wanted to make it more, let's say I did want to get that last one on there, I could do index 2, or I could do index -1. But let's just do it this way since I already typed it in, and Suzuki, and the program does not crash. Okay, so that's it's something that we need to be aware of, is this off by 1 index error that happens, you know, quite a bit. It can happen in loops, or maybe you're just directly trying to access a particular element on here. So let's go on the next one here. So this approach will always give you the last element in the list. So we've got a list here on line 3, and I'm accessing the last one. You know, it's going to say Suzuki, and then I'm going to use the pop method on line 5, and you know, when you do that, it gets the last one, right? So then when I say motorcycles of -1 again, it's going to give me Yamaha. See the results here? So the idea here is that this approach will always give you the last item in the list, even if your list has changed in size. So we did change the size of it by using the pop method. And this last one over here, let's go ahead and see what we've got. We've got when will the question is posed, when will index -1 cause an error? So the idea is this: on line 3, I have a list and it's populated, and I say, hey, I want the last one. So let's just go ahead and run it, and yeah, it works, right? But then on line 6, I create another list. This one's called motorcycles. The one above it was called my motorcycles. Now on line 6, this list is empty. So that when I uncomment the offending line and I try and ask for the last item in the list of motorcycles, see what happens. I get an exception. What is the name of this exception? Index error. List index out of range. It is happening on line 8. It's very important that we learn how to interpret and read these tracebacks so that we can understand how to fix them. So basically the idea here is the only time you'll get an error like this is when, you know, you end up your list is empty and you try and use the -1 on there. So the chapter closes with like another try it yourself 11.10 or 11 or 3.10 said try every function in the book. I'm not going to do that one. And another one, the 3.11 says an intentional error. I think we've done that. If you ever received an index error in one of your programs, if you haven't, try to make it happen. And all you have to do is just try and all you got to do is access a line number that does not exist, like we did here. That was kind of repetitive, so I didn't build that. Something we've already done that. So that's the end of this chapter. So what did you learn in this chapter? We learned what lists are and how to work with individual items in the list. This was the first part of the chapter. We learned in the second part of the chapter, we learned how to add and remove elements. Actually, it was done in the first part of the chapter. We learned how to define a list and how to add and remove elements. We also learned how to sort a list permanently and temporarily, for display purposes. We learned how to find the length of a list, and we learned how to avoid index errors when you're working with lists. We just have to be aware of it. We have to master zero-based counting. That's what we have to do. It wasn't very clear a technique to avoid index errors, other than just don't do them and understand how zero-based counting works. So what are we going to do in the next chapter, chapter 4? In the next chapter, we're going to learn how to work with items in a list more efficiently. We'll learn how to use loops, to traverse the index value. So it's we're going to be a lot more powerful. We're going to learn how to use loops We're going to learn how to loop through the items in a list using just a few lines of code, and you'll be able to work more efficiently, even when your list contains, well, thousands or millions of items. Okay. Well, my friends, we finally came to an end, of this chapter. I hope that you found it, informative. I want to close this chapter out by reminding you about the author's cheat sheets. If you go to his website, you'll see this one on lists. Now, this topic of lists, or this cheat sheet, is a summary of not only all of chapter 3, but chapter 4. So you'll see a lot of topics on here that we haven't covered yet. But what we covered in chapter 3 is we learned what a list is. We learned how to define a list, how to access the elements in the list, and how to modify individual items in the list by using, an assignment statement, right? Then we went on to add elements with the append method, and we also learned how to insert elements with the insert method. We learned how to remove elements with the delete statement, and then we compared that with the remove method to remove an item by its value. We learned how to pop elements by using the pop method. And if we want, we can use, when we use pop by itself, it always pops the last one on the list. But if you use an index value, we can go ahead and remove that particular one on the list. To find the length of your list, we use the length function, and we pass the list to the length function, and it returns the length of your list. When we got to sorting, we learned that there was the sort method, which changes things permanently, and that there was the sorted function that returns a copy of the list and leaves the original list unchanged. And that's as far as we go. Our last topic was on, say, for example, the reversing the order of the list. So looping through a list is going to be the nature of the next chapter, chapter 4. And just to look at it, we're going to cover looping, the range function. We're going to work with simple statistics, copying the list comprehension. Some people consider that a little bit advanced. Styling your code, tuples, and visualizing your code. So the next chapter is going to be a lot more challenging than this one. So you see, like, each chapter in the book increases in intensity. The first few, the intro and chapter 1 and chapter 2 were like kindergarten, first grade. So we're rapidly moving into some deep water here. So I highly recommend that you keep up with your readings and that you type in a lot of the code from the book, because the style that he uses is a good style, and it's something that you're going to want to emulate. It's a good coding style, and he talks about readability, and we'll talk a little bit more about things like PEP8 and stuff like that that we want to comply with in order to have our code look like Java code. So look like the kind of code that it's used to maintain code in large enterprise companies. So that's all I've got to say about chapter 3. We need to start getting ready for chapter 4. Professor Benavides, over and out.